Hello and welcome to Intro to Python for Maya Artists. I am Justin Israel and this is the first part in a series of videos I'm going to be doing on Python scripting language in Maya. We might even be doing some other Python-based videos in some other languages, maybe Nuke, but for now we're looking at the Python series, and this being the intro course, this is really geared towards first and foremost artists who may have not ever seen Python before or have maybe played with the language a little bit, but really we just want to give you everything you need to start writing some code in Maya and solving some daily problems. Our goal at the end of this is to give you a fundamental working knowledge of the basic commands of Python and how they can be used in Maya, and we want to bring a level of automation into your daily workflow, and this really gives you a lot more power as an artist to be able to solve problems quickly as opposed to manually, things that you could have done automatically even. So this being an intro video, again, if you know Python, this may be a bit redundant for you. If otherwise, this is a good intro course for people who don't necessarily want the entire Python toolbox, but maybe just want a hammer and a screwdriver. So we're going to give you a hammer and a screwdriver. So I want to talk first about So let me start by saying why Python? Why should we learn Python as artists? And the reason for that is that Python is very established and widespread. It's very fast to write and very easy to learn because of how easy it is to visually read and understand the concepts. And it's also been introduced into Maya since I believe version 8, and a lot of other visual effects software packages are adopting it as the common scripting interface because it's cross-platform. Nuke, very heavily integrated into Nuke. Houdini, C4D, Blender, 3ds Max, Fusion adopted it. They used to have IonScript, and now they have Python built in, and a lot of other applications let you run it natively to control the interface and write tools and whatnot. So that's really why it's great to learn Python. It's just cross-platform. So that's really why it's so great to learn. It's cross-platform for so many packages. Now I want to talk about a real-world problem. So let's launch Maya, and you have to forgive me. We're in a slightly cropped view here, so we have a smaller Maya space. But what I want to do is present a real-world problem, and I'm going to bring up. So first, I'd like to introduce a real-world problem, something that we can start off by looking at, and then over the course of this tutorial, we'll be able to actually address the issue. And so I'm going to open up a project area, and we're going to include we'll include these scene files for you, so you can follow along with us. So in this intro, we'll have a lot more stuff here, but right now we have this Canon deck scene. And I'm going to go in here and I'm going to look at these scenes, and I've created two, but let's assume that this Canon deck scene was given to us by another artist and on his own machine, and he had it set up the way he wanted, and we took it from him and we organized it into a nice workspace. And I'm going to open this up. And what you can see is there's no textures showing up. And let's look at why that could be. So we can click on one of these, and let's go over to the textures here. And as you can see, the textures aren't showing up. And what happened is his textures are located on somewhere that's common to his machine, but it's not on our machine. We don't have this full path, and Maya's trying to look for it in the wrong place. But there could be, in this scene, there's probably about 40 textures, but in even larger scenes there could be hundreds of textures, and you don't want to have to go through all these file nodes and change the paths by hand. So the idea is we want to try to solve this problem by changing all the paths in all the textures to a path that is appropriate for our machine, so we can fix all the textures. So we'll get back to how to address this after we look at the basics of Python. So next, I want to open up an interpreter, and we're going to open up a Python interpreter by loading up terminal. I'm on a Mac, so I have terminal. Linux has terminal as well, and if you're on Windows, you can get to terminal. It's the command shell, and you don't have Python installed by default if you're on Windows. So you're going to have to go and download Python. It's not necessary, but if you just want to play with it like I'm going to show you here, you can download Python. We'll include a document with this video, and we'll show you how to install Python on Windows. But if you're on a Mac or Linux, you have it already. And on a Mac, you could get to terminal also by typing in terminal here and hitting enter from Spotlight. So we have terminal open, and what I'm going to do is I'm going to type the word Python, and that puts us into a Python interpreter. Now Maya has this built in, and that's how it processes all the Python code that you give it. But you can run this by itself and kind of play with it like a sandbox, and it's a really good way to learn and test the tools, test all the code, see what it does. You're not going to break anything, and it's just I to this day pop this open and keep it open and test all kinds of little snippets in here just to remember what things do, because I can't remember everything all the time. So I pop this open, and I'm going to start going through the basics of Python. So to start with learning Python, and again, this isn't going to be a comprehensive A to Z Python lesson here. We're just going to give you, like I said, just the hammer and the screwdriver and the things you need as an artist, because that's how I want to gear this tutorial is an artist, only the things you need to get started. And as you go, you'll pick up more stuff as you find a need for it. You can always Google the specifics on Python or get a Python book, and so we'll get into that. But to start off, I want to talk about Python. It's an object-oriented language, and that means object-oriented. Everything you deal with in Python is an object. It's a smart container. So what do I mean by that? There are types in Python, and Python sees these types and knows how to use the types. Let's just give you a couple examples of the types there are. There's an int. An int is just a number without a decimal, 1, 10, 100, 1,000. There's a float. Float is any kind of decimal number. There is a string. Strings are words. There's another one called a list. And there's a tuple, and there's also a dictionary. Now these are just the basics. There's a couple more than this, but these are pretty standard, and these are kind of what you'll use as you write your basic scripts, and you'll learn more as you go along. So let's give you examples of an int. An int is 1, 100, 1,000, and I'm just typing these and hitting enter, and it's spitting it back to me. But you could also use the keyword print if I wanted to print a lot of things. So you can put print in front of anything and it'll print it. So moving along here, we have these objects. Now these are just values, but if we want to basically look at an object, if you remember math, back in math when you had to use variables and you thought you'd never have to use them, well, let's start using them now. So if I type the letter x equals 1, and I could say x is anything, but in this case let's just call it x equals 1. And I can print x, and x is 1. I've given it a value. I can set x to 2. I can do math. Now, Python knows how to do math because it knows what to do with int objects. I can do 2 plus 3.14, and I get decimal precision. Now, I can create a float. I can say f equals 3.14. Print f 3.14. So I have f and I have x, and I can do f plus x, and it did the math and it kept the precision because it knows when it adds a float and an int to keep the integer precision. And let's do a string. Let's say s equals hello world. I can print s hello world. And now s is a string. Python knows it's a string. What happens if I do s plus x? And if you remember, x was an integer. We get an error. Python's telling us it doesn't know what to do when it's putting a string and an int together. You have to be more specific, or you have to help it. It needs rules to help bring those together. So it knows how to do numbers, but it doesn't know how to do a string and a float. Why? It's because it's an object. And now let me introduce, now that I've said objects, I'll show you a bit about functions. There are functions. Here's a good one called type. Type is a type function, and any kind of function can be called with parentheses at the end, and if you had any parameters, you would put them inside the parentheses. So type takes an object, and you can say x, and it tells you what kind of type that object is. X is an int, S is a string, F is a float. And that's how you use a function. If this type took more arguments, you could put more arguments in here like that, but we're not going to do that. And another interesting function when you're learning is the dir function. And what you can do is you can put an object in there as the parameter, and it tells you what's inside of it. Now this is where we're getting into the idea of objects being smart containers. So for our purposes, just ignore all this stuff with underscores. That's all built-in things that make this object do the cool stuff it can do. But for our purposes, we want to look at all this other cool stuff that's here, and I'll tell you why it's cool. Don't worry, I'll explain why it's cool. It looks kind of nerdy to start, but it's cool. Trust me. So S. Now, if we want to access any of these things, we can pick. Let's see. Let's do title. To access any of the child items, you could say dot title, and the dot tells it you want to access this title child of this S string. Now, if I just hit enter, that's telling me that there's a method of this string called title. Well, if I want to run it like we did with the type command, I just put the parentheses in here, and when you see what it did, if I print S to compare it, it capitalized the string into a title format. And there's some other ones in here too. There's upper. I could do s.upper, hello world. I could do s.lower. If we actually had capital letters in there, it would force everything to lowercase. Now, an interesting thing is, how do you know what to do with these things? Well, you can look at documentation, you can Google, but you can also use this help command, which is really great for learning. So you can put in s dot, let's say upper, and hit enter, and it gives you some help. And it says, here's how you use it. S dot upper returns a string, returns a copy of the string converted to uppercase. I'm going to hit Q to get out of this. So that now we know how to use upper. Well, let's pick another thing to use. Let's try replace. So I'm going to type replace and hit enter, and this tells us that replace actually takes some arguments. So replace needs an old string, a new string, and optionally how many times it should try and replace it, and it'll give you back a new string. So I'm going to hit Q to get out of this. I'm going to type S replace. If I hit enter, I get an error saying, hey, remember this takes at least 2 arguments, so I'm going to hit up on my keyboard just to get that command back. And what I can do is I can type an old string, so let's say world, and a new string, u, and if I hit enter, it replaced world with u. And if S was hello world, 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 and I did this again, it replaces all of them. But you remember that optional one it said we could do? We could say only do it once, and it's only going to replace the world once or twice. So we've got this replace function, and it's actually called a method because it's a child of a string object. So that's the idea of object-oriented. This replace knows how to work on strings, and it's called a method of a string. It couldn't be at the top level because it doesn't know what to replace. It doesn't know if you gave it a list, a string. That's not how that works efficiently. So what we want to do is say replace this string, whereas a function is just one of these loose commands, type, help, things like that. So we've got the basics of objects and we've kind of looked a little bit at functions here. I'm going to go over a couple more variables here. Let's try looking at, we've looked at int, we've looked at float, we've got a string. Let's look at a list. List is pretty important. So a list, and I'm going to say my list, and I could say anything I want. I'm creating my own variable. It's just a label. It can be anything we want it to be. To do a list, you use these brackets, and you just put comma separated whatever you want inside here. I can even put a string. I could use the variables that we've already defined, and I can hit enter. And if I print my list, now I've got this list of items. And the thing that list can do, if we do our, remember our dir command, you see these things it can do. You can append to the list. You can count how many times something happens in a list. You could extend it with another list, insert to a spot in the list, pop one off, remove, reverse the list. So let's try that real quick. Let's say my list reverse. Print my list. Now you can see it's backwards. And the way you can work with parts of a list is you can say my list, and you use those brackets again, and you give it an index. And in Python, lists start at 0 and go upward. So this would be 0, 1, 2, 3. And what you do is you say, I want the first item, which is 0. I'm going to put up again the second item, the third item. Now, how would I know how many? If I just had this list, how would I know how many items are in there? Well, there's a function that tells you the length of a list, and it's called len. And I can put something in there like my list, and that's how many items are in that list. And funny enough, len also works on strings. That tells me how long the string is. And if you remember, that's our string. It's 23 characters long. So what can we do with a list? Well, we got just one item, but what if we wanted to get a part of the list? What if I wanted to get the first, the second, and the third items in this list? I could say I want it to start at the beginning, and I want it to end. Now I actually think you want this. We'll give you the first, the second, the third, and then it stops right here, which is 3. So that's kind of the range. It's start from here, 0, 1, 2, 3, and you see this range that you would get. You can also do negative indexes from the back. If you remember, that would be backwards, -1, -2, -3. You can even play around with doing -1 to -2. Oops. Actually, you want -2, like that. And you can get backwards ranges on the list. So this is a really cool way to contain a bunch of items and get pieces of them out. And you can even set, say you have my list and you want to change the second item in there. You can set the second item to a new value. Actually, that was the third item because it's 0, 1, 2. Alright, so that's the basics of a list. And if you notice, we were able to change the values of the list like that. And that means that that's a word called mutable. This list can be changed. Now, a string, if you remember here, can also be treated like a list of characters. So if I do 0, I can get parts of the word. You see? I can even do a range and get pieces of that. But what happens if I want to change a letter in here? We can't do that because a string is not mutable. You can't change it once you've set it. You could make a new string. You could copy it over to a new string and change it, but you can't change a string. And so that's the other type of container that's similar to a list, and it's called a tuple. And a tuple is kind of like a list with less functionality, and the way you make it is if we do my tuple, and you remember lists were like this. Tuples are exactly the same except you change and use the parentheses. And the only difference, if you look at my tuple, you'll see that it really doesn't have anything other than count and index that you can do with it. And that means that it's not mutable. You can't change stuff after you make one. So this is good for stuff that doesn't change over time. I can still do this. I can still get the indexes. But if I try to change one, can't do that. So tuples are great for things where it's a set of stuff that doesn't change over time. It's a set of things that are fixed for the time of the program or the time you're using it. You could do like a set of colors, red, green, blue, and those are the colors we have to work with, and we're not going to change those. The last thing is a dictionary, and you won't necessarily need this right away, but you will want to use it as you get more advanced. So a dictionary, just like we had brackets for a list, parentheses for a tuple, and these braces are a dictionary. And the way you can do a dictionary is really cool, is you can define a key. So you can say my key. Actually, let's do something easier. Let's just say red. And we're going to say red is 1. And then I can say blue is 2. And hit enter. And I'm going to print. And now we have this dictionary, and you can look up values. And the way you look it up, just like with lists and strings, you use these brackets. But instead of putting a number in here, we're going to use one of our keys. And that tells me it's 2. I can put red in here, and that says 1. And you can even set new keys. Just like that. So this is a good way to store values that have associated words with them so you can look them up again. And you'll see that being used when we go into Maya. And so that takes care of the basic variables. And next we're going to show you how to do functions. Okay, so functions. You've seen a couple of the built-in functions, like type, dir, help, and you've seen some methods too, methods that being the functions that are attached as children of objects. But we can make our own functions, and the way you make your own function is with the keyword def, meaning define, and we can define a function called, let's call it test. And just like you remember when you call it, you put these parentheses here, and you can put in your own variables, but let's not do that yet. Let's just end this with a colon. And in Python, when you type your code, it requires that you indent as you go. So that's how it tells the difference between blocks of code. So once I put this colon here and we hit enter, we can keep going with our command, and we hit tab, and now we're inside of our test function that we're writing. Some other languages use braces around here to tell you where it starts and stops, and doesn't care so much about tabs or spaces, but Python wants consistency with spaces. So I use tabs, and what I can do is I can print hello world, classic hello world, and hit enter, and then enter one more time to commit that. So I've created this test function, and you remember we call a function by adding the parentheses at the end, and if I do that, it prints hello world, because we told it to print hello world, and it doesn't really do much else than that. If I wanted to pass it a value, it gives me an error because this function doesn't take any arguments. We didn't tell it to. But we can make a new one that takes a variable. And now I've called it input. We can call it anything we want. It's a placeholder. It says that this first parameter that I've said I want will be called input inside my function. It doesn't matter what it's called outside, but when it's given to me inside this function, it's called input. And so I can say print input, and now when I run test2 and I say hi there. Hi there gets passed in as the input variable, and now I can work with it in here and print it. I can even do stuff like add, and I can say x, y, and I could print x plus y. Now if I do add 1, 5, it does it for me. And that's just printing. So the problem though is nothing is being saved when I'm printing here. This function is doing something and it's printing something, but I can't do anything with the result. So that next concept is the return value. I can have my function give me return value. So if I change my add x, y, and I return x plus y, this says give me back this value. And anytime you put a return in here, it's going to leave the function and return back what you give it. So if I do add 1, 2, it prints 3, but I still haven't saved it yet. What I can do is I can save it, just like we did creating our other variables. I can say value equals add 1 plus 2. Now if I print value, I've captured that return value. And I could have called this anything I wanted, but I called it value in this case. And now value, let's see what type it is. It's an int. So Python again knows that when you add these ints together, it should give you back an int, and it's given you an int value. So we understand functions and how to give them arguments, as they're called. These are arguments, and how to do a return value. Let's try something a little bit more complex with a couple more lines in there. Let's create a new function, and we'll call it complex. It's complex for us because we're learning right now. And we're going to take a couple different values. We're going to take a number. We want a number, and we want a word, and we want let's just do a number and a word for now. And now let's add them together. So you remember before we tried to add a string and a float, and it gave us an error. It didn't know how to put them together. Well, what can we do here? Let me cancel out of this and try this one more time. I'm just going to go ahead and scroll through what I was talking about with creating a more complex example here. So remember when we tried to do word plus 1, and we got this error right here because it didn't know how to put together a word and a number. But we can you remember we have these functions for creating new objects, string, int, float, like this. And what we can do is it's just like a function where if I said float 1.3456 equals value, that's the same thing as saying 1.34. It's just a shortcut. So it's like having this float wrapped around, but we don't need it because Python is smart enough to figure it out. But knowing this, we can actually use it to convert one type into another type. So if we do this, if we do 1 and we wrap it in this string command, it converts that 1 into a 1 string. Now if we put these two together, you'll notice that it makes a new string. It first converts this 1 into a string, and then it knows how to add strings so that you get this new string. So that's how we can fix adding these types, by turning one type into another type. So let's try writing this this new function here. Let's call it toString. And our toString is going to take 3 arguments, and we just pick 3 arbitrarily, A, B, and C, and they can be anything. And what we're going to do is we're going to pass those in, and for each of these we're going to turn them into strings and add them together. And so we have that, we commit that function, and then we run toString, and we just put an int, a float, and a string in here as parameters. And what we get back is a string of them all added together. Now if we hadn't done string on each of these, this one would have failed because it's an int trying to, well, you can add these two together, but you can't add this string to these two in this case. So we make everything a string, we add it together, and then we get this string output. So that's how we change types. So now I'm back to where I wanted to be again with moving on to talking about modules. And now all this stuff is great, built-in things, but it only gets you so far. So what they do in Python is they break out all this extra functionality into things called modules, which are like libraries. And they're broken up into logical categories. So here's one that you can import. And the way you import is with the import keyword. And there's one called math, and there's a whole list of them, and you can look them up online. But math is a good one that has all kinds of more advanced math functions. And you could get help on any of these. You could get help by just doing math and get the entire help, or you could pick one. And let's just get help on floor. And floor, what it does is you give it a value, and it gives you the closest lower integer value. So we're going to do math. We imported math like this, and that gives us the math module and the floor function. So I can put a number in here, and you can see that it gives me the closest lower integer. So even if I went to 99, it just basically lops it off to the closest, basically gives us back this, but it gives us a float. And they have the similar ceiling up to 4. So you can see that a module gives you all these extra functions. There's another one that's pretty useful called OS, and these are all kinds of operating system functions. All kinds of crazy stuff, a lot of these that you will not need to use, but you can look through the help and see what all this stuff does. I'm just going to hit Q, but I'm going to throw it out there that that's how you can look up all this stuff that it can do. You can make directories, you can remove directories, rename, all kinds of stuff you do on a file system. You can call out to commands by OS system. We don't need to get into that right now, but the idea here is that modules give you extra information, and that's what you will need when you go into Maya and you have to use Maya's modules with all the custom commands that it has. One other thing is just how you import. There's a couple ways. We did import OS, but you could also say import OS as some other name. And that just means that I imported OS, but I renamed it to something else. And that's useful if it's a really long name and you want to make it shorter. And one other thing is OS has another module inside it called path. So you could, it's just a subcategory. So you could import, actually, say we don't want the whole thing. We can say from OS import path. Now we just have the path module, not everything above it, and it's a lot shorter to type. By the way, path has a lot of just specific to working with file paths, like is it a link, is it a file, is it a directory. Let's try that real quick actually. Let's try is dir, and we'll give it something that I know, the user's directory. And it tells me true. And that's another type that I actually left off. That's a Boolean. It's either true or false. So we have bool. That's another common type here. And that can be either true or false. So that's how you import modules, and we'll get into more of that when you get into Maya. And now I want to give you some examples of loops. Loops are ways you can do the same thing over and over again by changing the value. And the first basic way to do a loop is a for loop. And a for loop looks like this. You go for, and then you say what you want each item to be every time you loop. So I'm going to say I. Every time we go in a loop, I will be this current item. Now what can you loop over? you can loop over a list, you can loop over a string, you can loop over anything that's a container of values, a sequence of values. You can loop over a range of numbers, and there's actually a built-in command called range, and you can give it a number, and it'll generate you a list that you can loop over. So those are different ways you can loop over something. But if you remember earlier, we had my list. Let's loop over that and print each value. So what we do is we do for I in, which means inside of, my list, and you remember the colon to go into it, because it's almost like a function, but we're going into it. So now this is going to go round and round for every value in my list, and I will be each value in this list. So let's just print I. And you can see that it went through every item in the list and it printed it out for you. So let's make this a little more interesting. Let's make a new list. Let's say new list equals an empty list. There's nothing in it. And let's say for I in my list. And let's say new equals I plus some more stuff. Now that might have a problem, because if you remember, you can't add strings to other things that aren't a string like that. So let's just make sure that this will be a string every time that we go around. So let's hit enter. And now we can keep going here. The first thing we've done is we've added whatever I is this time plus some more stuff. And now let's do new list. And if you remember, a method of a list is append, and we could have done that by doing the dir command and seeing what a list can do, but we're going to append this new item to our new list, and I'm going to hit enter. Now it didn't print anything because we didn't tell it to print, but let's print what our new list is, and you can see that it's every value from the first list plus some more stuff. So we've changed it, we've made a new list, and we could even change the list in place. If we loop over the same list, we could say my list. Actually, we need to do this slightly differently, which is good because we can get into looping a different way. So what we want to do is let's loop over the list and change each value in the list in place. So you remember that to get the length of a list, we can get the len. And I also told you that you can loop over a range like this. So if we put all that together, we can say len my list and then wrap that in a range. You see what I did here is I put, and you can put spaces like this, it's fine, len my list inside of a range. And now we've got something we could loop over, and I can say for I in range. Now I last time was each item in the list, but I this time is going to be each item in this list. So if we hit enter, I is going to be 0 this time. So if we say current value equals my list I, that means that it's going to pull that value out right now and save it in here. And now we're going to say new value equals current value, and remember we want to make sure that this is a string, so let's wrap it in a string plus some more stuff. Now we also want to save it back over the original, so let's say my list I equals new value. Now if I hit enter, nothing happens. So now what do we expect to see? We looped over my list and we changed each value. You've overwritten the original list. So that's how you loop over a list and also a length of a list to get the number. So whatever you're looping over, that's what each item is every time. There's another type of loop called a while loop, and a while loop will run as long as the statement you give it is true. So you say while, and you give it a statement here. And what you can do is you can say I equals 1. We'll just start a counter at 1. And we say while I is, let's do it 9 times. So we'll say while I is less than 10, print I. Now what happened here? It's looping forever. It's never going to stop. I'm going to hit Control C and break it. Why did it not stop? Well, because I is always 1 the whole time. We never did anything to I. So we need to say print I, and we need to make sure I changes every time. So I can say I equals I plus 1. Now when it goes back around, I will be 2, and then it'll be 3, and then it'll be 4. And let's see what happens here. Now it works right. So we've got the for loop and the while loop. And you're seeing that we're doing a test here, which leads me into talking about how you test things. You still hanging in there with me? Alright, I know there's a lot of command line stuff, but we're just going to get through the basics here, and then we're going to move into the more graphical stuff. So let me just show you how to test something. And what you can see here is we have 1. And we can say 1 less than 10. That's asking a question. Yes, it is less than 10. Is it greater than 10? No, it's not greater than 10. You can test if something's equal. Now, why did we use a double? Because if we did a single, we're trying to do an assignment, and you can't say 1 is 10 because that's actually not even possible. But if you remember when we said x is 1, that's how you assign something. But then you can say, is it 1? It is 1. So using that, we can do something called the if statement. We can say if, and then we put a test here. If x equals 1, and you remember our colon, let's jump inside the if statement, print it's 1. See, and x was 1, so it printed it's 1. And you can have an alternative thing happen. Let's just say true. You can say if it's not 1, else, and this is anything else than 1, print false. And there you go. That's how you get the false statement. And you can even do multiple ones. You can say if x is 1, print blah, elif, and that's a short way of saying else if. I know they could have said else if, but they made it elif. X is greater than 2, print true. And you don't even have to have another else. It just means nothing else will happen. So x was equal to 1, so it's blah. So now we know how to do if, else. These are how you test things. It's basically just testing if it's true or false. And you can also test a string. You can say if hello, print true. Now why did that print true? Well, that's because if hello is anything but an empty string, it's true. And each type of object has its true and false value. 0 or 1 is true or false. An empty string or something in it, that's true and false. An empty list versus a list with something in it, that's true and false. Same with a tuple, same with a dictionary. If there's nothing in it, then it's false. If we had a my list, so you can say if my list, print true. Yep. Now what if we did that on an empty list? Nothing, because it's not true. There's nothing in it. So that's how you can test if you have anything in your list or not. Now I think that this is pretty much all you need to know to get started messing around with Maya. These are all the basics. You can get a lot more by going to python.org. Do not go to python.com because you will see a lot of adult content, and I'm not responsible for that because I warned you. So don't go to python.com, go to python.org, and you can go to the documentation, and they've got things like the tutorials and library reference, language reference, and just basically getting more information on all the stuff that I've just been going over. But that's not really important to us at this point. That's for you to do in the future. So we're going to go ahead and move into Maya and start doing some more visual stuff. Home sweet home, much more comfortable, huh? So now you made it through the command line, you got your hammer. You got your hammer in your hand and you're swinging it around in the air and you're ready to build a birdhouse, but we're not going to build a birdhouse just yet. We're going to learn about the nails. I don't know where I'm going with this, but anyway, so we're in Maya and we're going to open up the script editor. And you may have opened the script editor before to check the output of what Maya is doing, but maybe never typed anything into it. But this is the primary area where you will be experimenting with your code. And it's got the Mel tab, it's got the Python tab, and you can use either language. Obviously, we're learning Python, but Mel was the original language in Maya, the Maya expression language, and it's a much stricter language. It's not object-oriented like we explained earlier. Everything is not as flexible, and you can't really accomplish quite as much. But with Python, you get all kinds of extra functionality, like things working with the file system and all the great modules that have been written for Python, all the crazy stuff you can do with Python. So it's much more flexible. And you can even switch this one-liner down here to Python. It's a little hidden right there because my screen is small. But to show you the difference in Mel, if we do some things, let me first start by making sure that we're echoing all commands. This will spit out everything that we're doing here. But if I go here, and you see as I start to do operations, it's printing out a lot of stuff here, right? And it's printing out a lot more because I said to show everything. But what it's doing is it's running tons of Mel commands to execute everything that goes hand in hand with what I'm doing here in the UI. You see it created the sphere, it changed the UI over here to update, building all the nodes and making the selections. And we can look up higher. Let's see, let's go way up here, and you can see here's where it actually created the sphere. And this is Mel. This is Mel, and unfortunately it doesn't spit out Python. It still spits out Mel. So you can only see the results of Mel commands here, but this gives you an idea of what Mel looks like. You have a command, and then you have these flags that are all the options to create the sphere that I did visually. But let me scroll down to the bottom here, and I'm going to turn off echo all commands because that gets pretty messy, and I'm even going to clear this area. But the difference here is Mel versus Python, you have much more flexibility. Like I said, Python is the modern language that's cross-platform, so that's why we're sticking with Python over Mel. It's just, it gives you more flexibility. Now, if you remember from the command line when I was talking about importing modules, that comes into play now in Maya, because whereas Mel was a native language where you can just start typing a command and it's ready to go, Python is an add-in to where you need to actually import the Maya Python module to give you all the commands. And the way we do that, if you remember our import command, the Maya module is actually called Maya, and a bunch of things live under Maya, but what we want is the command package, which gives us all the commands that have the equivalent Mel. So what it is import Maya commands, and that would bring in the package. But a very common way to do this more cleanly is to say from Maya commands. Actually, it's import Maya commands as commands. And I'm just going to hit the return key on the bottom right of the keyboard to send that command. And what that does is it imports Maya commands but just aliases the name to command. So if I type commands and hit enter, it tells you that it's got the module Maya commands, and it even tells you where it grabbed it from off the file system. So we've got this commands module, and that's where we can actually run all of our Python commands. Now, I told you before about the dir command to look inside of objects, and if we run that here, we'll see there is a ton of stuff, and this isn't really the best way to look at this. So I'm going to show you how you get your information about how to use the Maya commands module. Now let's get a couple settings going in the scripts editor here. Let's look under the history tab and make sure you have what I have checked. We want to see line numbers. We want to see stack trace. This is if you screw up stuff, you get errors. You'll get a nice output of what went wrong. And under the commands tab drop down, we want to show line numbers, and we also want to turn on command completion and object path completion, and we want to turn on the quick help. We don't want to turn on the tooltip because I think it's very annoying and it's not quite as helpful as it could be. So with those on, we get this nice help thing, this help tab on the side here, and we've got our commands. And what you can do is, the first way to get to help is under the help section. There's the MEL and the Python command reference, and if I open this up, it's going to open a web page. Now unfortunately I have Chrome as my default browser, and there's a little bug in Chrome where the search doesn't work right, so I'm just going to minimize this. I have it open already in Safari, but what this gives you is the entire language that's available to you, the commands reference. These are all the commands that you could possibly run with the Python module, and they have the MEL equivalents. So the things you see in the script editor spitting out, they have these same things here. If I type sphere, sphere, and I click on sphere, you get this full help screen of how to call the sphere command and all the options it takes, and it tells you that it returns a string. And now this is kind of some of the stuff that's still MEL-like, where these little brackets means it's an array, it's a list. So what you're going to get back is actually a list of object and nodes that it created. And here's all the flags. It tells you everything that you can do and the shorthand terms for the flags and what type of values they accept. So we have this reference. Let's go back to Maya, and let's work with that sphere command again. Now we're not going to do much with the sphere. We're just going to show you how to use the commands. If I type commands and I hit a period, because we know that's how we go into the commands, if I hit the control spacebar, you get this cool pop-up, and it tells you all the stuff you can do, just like in the web page. So let me hit backspace here. Actually, backspace. Dot sp. See, it's narrowing it down. Sphere. So it helps you find these commands in here. And one of the cool things is now it's waiting for you to put the parameters in here for sphere. But I can click on sphere, and I can right-click, and I can say quick help. And what this does over here is it gives me all those flags from the web page. Now the downside is it is still in MEL format. So Python doesn't use these dashes in front of the parameters. They just use the actual letter or the full word. But these tell you everything you can do, so they can give you a quick help. If you were using MEL, you would just double click and it would start putting them in for you, but we're not in MEL, so we can just use it as a reference. So you can get the name, and you can get all the other variables. See, a name takes a string. So that's how you would build up your parameters, and then you would run the commands. And to run the commands, you can select them, and you can hit. Now if you hit enter, it runs the command and then it goes away. But if you select everything and hit the bottom right return key, it runs your code, and it still keeps the code here, which is really cool because you don't have to keep typing stuff. And when you're testing and you're running lots of code, you can select parts of it and hit the return key, and you can keep testing it over and over again. So how do we save and load our scripts? Well, if I have this code here, I can select it, and if I had a lot of code, I could select all of it. File, save my script, and we can go into my project, and I can create a new directory called scripts, or wherever you want to save them for now. I'll go inside here and call it first script. And I believe if you save it with that extension, it'll figure that out for you. So we've saved it. I'm going to delete this, and we can get our script back, or we can hand it out to other people. See, we get our scripts back. So this is how we can build scripts and save it out. And if you notice, when you type in here, you get the benefit of this highlighting. It helps you see your code really well. And when you type a string, it turns nice colors, so you know when you have errors, when things don't line up properly. Now what I'm going to do is I'm going to illustrate some of the things that we went over in the command line. And I'm just going to do them as examples here so you can see them in use. I'm going to do a new scene and clear this up here. And let's keep going with that sphere, and let's just see the concepts that we learned. So let's do commands, and then I remember control spacebar. We can start narrowing it down. Sphere. Right? Now, some of the options that sphere takes. I'm going to pull back up the web page again, and some of the things we can set. We can set the radius, and we can see that the radius takes. Now they call it linear, but they tell you here what it means. It takes a float value. It's any decimal number. It could be any number, really. It could be int or float. And then we can also find, we can find name. So we can set the name of the object it's going to make, and that takes a string. So let's go back over here. And what we do is we want to do name equals, and you remember strings are in quotes. Let's call it my sphere. And then let's set the radius. Now you can either do the short name or the long name. If you look down here, radius can be R or radius. Sometimes it's nicer to type the whole thing so you can see what it does. Let's do a radius of 10.5. And we don't put that in quotes because this is a float. Now, remember I said if we highlight the whole thing, actually let's actually make sure we save. I remember telling if we run a function, we can save the output by saying my sphere equals. And we can call this anything we want. It's our variable. And we say equals, and then the result of this command will go into my sphere. And I'm going to select the whole thing, and I'm going to hit the return key, and it made a sphere, and it printed the command for you. And what you can do is, let's hit enter, print my sphere. Hit enter. Now what you get here is a list. Now these U's in front of this is it means Unicode, because these can have non-standard characters in here, and it supports Unicode. So don't worry about these U's right now. It's still a string. It's a special type of string. But these brackets mean that we got a list back, and it actually said from the help here that we get back, and I told you that this is the Mel way of saying a list. These little brackets, it gives you a list. And it told us the transform, and it told us the shape. And you can see over here that it called it my sphere for us. Now, and also a little tip is you don't have to type print. You can click anywhere on here and hit return, and it's a really cool way to replay any of these commands. It's almost like printing, so it's really nice to develop. So we've got my sphere in a list, and we've got these two names, and so we've illustrated a string, a float, a list return value. Here is a function call. These are the arguments, the name equals and the radius equals. So that's a lot of the things we just went over all in one there. And what I can do is I can add a 2 on here, run this again. Actually, I'm going to call this 2 as well. Run this again. It made another sphere. I kept them in the same spot, but it made 2 spheres. And if I hit enter on this, we've got a second set, right? And we didn't delete, we just kind of erased the text for it, but we still have this my sphere list. So we've got the first one and the second one, and I told you that since Python is object oriented, I could add these lists together, and now I get, it knows how to do list math. I get a big list of everything. So you can see object oriented access to these. I can also, my sphere, I can get just the transform, or I can get the shape. because it's the first index or the second index, and I told you that the indexes always start at 0. And I can say how many items in this list. There's 2. Show you some more really cool commands, some basic commands. I'm going to create one more sphere. I'm going to call it sphere 3. We'll give this one a radius of 5 or something like that. Doesn't really matter. So we've got 3 spheres in here. Clean this up a little bit. So we've got 3 spheres. Now here's another cool command. Commands.ls. And ls is similar to on Linux, Unix, Mac OS. ls is a list command. It's a way you can list things in the scene. So we can list with no arguments, just lists everything. But we can actually fine-tune this, and we can say just list, and if you remember, we can actually type ls right here, and we get all the ways we can actually limit specific items. And one of the cool things is here is you could limit by type. So I can say type equals, and I could limit this by a NURB surface, since that's what we happen to have right here. So I can say give me back all NURB surface objects. Oops, I did equal. That's not, we don't want to do that. So if we hit enter, we get back a list of the 3 NURB surfaces that we created. And we can save this into spheres. And now we've got our list, we've got it saved. And we can loop over it, and we can do stuff with it. And if you remember how to do a loop, it was for. And we can say anything we want here. This sphere in spheres. Tab to go in, because you have to indent in Python. Print this sphere. I can select this code, hit enter, and it loops over each one and it prints it. Now we could do more things to this. We could change the size of the sphere, the other properties of the sphere. But I want to show you another command that's really useful, and that's the select. Commands select. Now if you look, when I select one of these, it's printing out the mel. So this is a great way, and actually before I get into this, I want to kind of jump over into how to learn as you go. And what you can do is you can perform operations and see the mel that gets spit out, and then you can do a whole set of operations and get the mel out of it and build your scripts repetitively with those commands. So you can see the select, and it's using the -r, which means replace everything else with this new selection. Now the Python equivalent, if we actually go into our help, we type select, we can go down to the bottom and we can see some really great examples of how to do a select. And you can see that you do select with the item you want to select and then the flags that follow. So what we can do is switch back over here, and we can say, so we're going to loop for this loop in spheres. So every time we go in the loop, the new sphere is called this sphere. We can select it, this sphere. We can tell it to replace anything else that was selected. That's kind of nice to do. And you can type select here, and let's look at the R flag, replace. It doesn't tell us, but it's a Boolean. If we look in our help, let's see here, replace Boolean. Remember, Boolean is true or false. So replace true, do a replace. And we can run this, and it would go through each of these and select them. And so it happened so fast you couldn't see it, and the last one that it ended with is the one that's still selected. But while it's selected, you can do anything like setting attributes to things that have to be selected. You could move it and do all kinds of things to affect it. And now I've said being able to set the attributes more than once, so let's actually see how we can set attributes. I'm going to go down a little bit out of the way. We're not going to worry about this code up here for a second, but I'm going to show you how you can change all the attributes. Now if you, again, want to see visually how you could do that, let's go into our channel here. And sorry about the screen size, I have to work with a limited space for the screen capture, but if I select this sphere, and you see it, we're selecting, and if I let's translate it a bit. Let's move it closer to the camera, and you can see it spit out the set attribute. And what it did is it spit out, first you have to give it the name of the object, and then dot the attribute. And if you remember, this is kind of object oriented, even though Mel isn't. The syntax right here fits perfectly with Python because this is a child attribute of this object. And then you give it the new value. And the way we do that in Python is commands set adder, and then we can either give it the name of the sphere, or if you remember, we have, for instance, we have this value already, and it needs to be given the actual transform because that's where this lives. So what we want to do is, now I'm going to put this in here and I'm going to show you what happens. We're going to set it to 5, and I already know this is going to not work, but I want to show you why. Now, we ran something incorrectly and it gave us what's called a traceback, and this tells us what happened, why it happened. We gave it a type error. That means that we gave it a bad type. It didn't like it, and it's saying that invalid argument 1 right here, and it tells us what it was, and it expected a different type. So what we actually want to do is, if you remember, this is the value of my sphere. What we want is this, and we want to say 0, but we also need to add the attribute name. So we can't do it like this. What we need to do is fix it first. So let's go up here to this line, and let's say my sphere 3 0. Okay, cool. So we got the transform, but we want to add on this bit of the string, translate z. And you remember that strings can be added together. So now that we've taken this from a list to the first element of the list, which is a string, I can add translate z with a dot. There we go. There's the string we want, and we could just say my adder. I do a lot of my because it's a good way to illustrate at this moment that it's my attribute. So we've got this saved. Let's put it right here. I'm going to move this over. Let's run it, and you see that it moved. And we can set it to 10. So what you see is we replicated the same mel command in Python. They just kind of swap the positions of things around, but you'll get the hang of how the object usually goes first, followed by all the flags and arguments and options that follow it. And obviously we can not only do the set adder, but we can also do the get adder. If we just change this to a G, and when it goes blue like this, it's kind of telling you that you got the right command because it knows all the members of this command. So that's kind of helpful with the coloring. But if I take off this value, because we don't want to set anything, we're just getting the attribute. If I select that, it tells us the current value. And I could save this to, let's call it sphere tx. Now I have this result, and I could do things to it. I could say, well, in our loop, maybe we want to move it forward. Oh, my mistake. TZ. Thanks for pointing that out, by the way. So we've got 20. Okay, great. So we're kind of onto something, which means we can move back up here into our loop before, where we were looping over every sphere, and we were doing something with it. We were selecting it. But instead of selecting it, let's use what we were already doing down here, up here. So every time we loop, we're going to see what spheres here. Spheres is the shape nodes. And actually, that's not what we want in this case. What we want is the transforms, right? So we got to format that first. We actually have to, what we should have done is every time we save these, we should have taken the first item. So let's do that real quick. Let's create a new list. Let's say, now if you remember my sphere, we have all these my spheres, and my sphere 0 is what we want, right? So let's create a new list. Let's say spheres equals new list, and then we're going to say spheres, my mistake here, spheres dot, and I could hit the control space and it tells me append. I'm starting to type append just like from the examples, and let's do my sphere 0. Oops, we forgot to do this first and put an R in there. Now what happened to, we had an empty list and we appended, we got our first item in there. We could also do, let's do it 2 more times. 1, 2. Let's run these. Now what happened here? We actually, oh, my mistake. We're doing this wrong here. It's actually using the same list over and over. That's not what we wanted. Let's clear our list. Let's start over. And what we actually want is my sphere 1, or 2, 3, and we want the first item of each of those. You remember we ran this 3 times. Sphere, sphere 2, sphere 3. So we can select this whole thing, hit enter. Let's see what spheres is now. Awesome, we've got our transforms. We've got our transforms, which means we can move down our code where it's going to loop over each of these spheres. And what we're going to do is we're going to get the current commands, get, and I can hit control space. Let's get the current attribute, and let's actually first remember we need to, what we need to do is we need to build it. So let's grab this code. See how it's great? We can just kind of shift code around in here and learn outside and then kind of construct things that work. So we're going to say on this loop, my attribute is this sphere plus translate z, and then we're going to get the attribute current tz. Call it anything we want. In this loop, this is only alive for now. In this loop, every time we loop over. So then we get the current z, and then we're going to move it forward. Let's say current tz equals, let's move it forward another 10. Now while I'm doing this little operation, I can show you a little shortcut in Python. This right here saying this current tz equals itself plus 10 can actually be shortened to just plus equals 10. That means add 10 into this value. Now that we have a new value for current tz, we're going to commands set attribute my attribute current tz. Okay? So let's again look at what this is going to do. We have our list of transforms. We're going to loop over that list of transforms, and every time it loops, the current one is stored in this variable. We're going to create an attribute name by adding the value of that string plus the attribute. So that's the current attribute. We're going to get the current value of translate z and store it here. We're going to add 10 to it, and we're going to set it back. So watch what happens with all these spheres right here. I'm going to select this code right here, hit return, and they moved. Now if I keep hitting it, they're leaving the screen completely. See, I can zoom out. They're leaving because we're constantly adding 10 more. So I could even turn this into a function. And if you remember, we were doing a function with the def keyword, move spheres, and you do parentheses, and that's where we would put our arguments if we wanted any. colon. Now, we need to indent this because you remember we jump into the function. So I select all this, and I hit Tab, and that moves everything over for me. Tab is what moves this over. So we're making this function called move spheres, and it's going to loop over these spheres, and it's going to do all this. But the problem is that spheres is only alive as a variable within this function. So we actually need to make spheres something we can pass in. Everything else we make on the fly, and we can make this an attribute later, but for the example, we need to pass spheres in because this sphere is only alive inside this function. So we have our spheres out here, we have our function. Let's make this. Now, it didn't do anything. What it did is it created a function for us. See, we have a new function that we could use, and I'm going to grab all these here. Oops, sorry. Sorry about that. My mouse wheel was kind of being weird. So let's do that again here. So we're moving it over here. I'm going to select these, and I'm going to set the z's back to 0. So we actually have something that we can see here. All right. So we've got our function, right? And let's go down here, clear out some space, and we've got our spheres list, right? We made that up here. We've got this function that we can reuse. So what we can do now is we can say move spheres, and we pass in our list of spheres. So this could have been called anything, and just to prove that, I'm going to change this to values, just because it could be called anything, and we just have to call it values while we're inside the function, right? Just to show you that we're passing in our spheres from out here, and when they get inside the function, they're going to be called values. So if I run this, you notice it keeps moving the spheres. It's looping over all of these and setting the spheres. So that gives us a really good example of a lot of the ideas we went over in making a function, doing a loop, passing in arguments, adding strings, getting the return value of the get attribute, adding to it with the new little way to do add, which you could also do a minus here, times, divide, all that for the math, and then setting that value back, and then having our nice function call right here. Now what I want to do is go back to our example scene that we had before in our projects directory in the Canon deck project, the Canon deck broken scene. Let's open this up just because it's something more visual than spheres. Let's look at it here. So we've got this scene, and what I wanted to do is, going a little further with our loops and some commands, something actually usable is, what if we wanted to select all the lights in the scene with Python? Let's open up a new tab. It's under the Command, New Tab, and it gives you an option if you want a Mel or a Python tab. So let's do Python, and we still got our old code over here, but we can move into a new fresh tab. And so we've got all these lights in the scene, and we want to select them all. So what we can do is going to do the ls command. So we want to list all the lights first. So let's type commands dot ls, and let's get some help on that. And ls has a ton of ways that you can look for different objects, but if you see, one of the ways is you could just say lights. So you can say ls lights. Now what does lights take? Let's open up our documentation, ls, and let's look at lights. It takes a boolean, true or false. So it's a flag. We want to say true. If I select this, hit enter. Here's all our lights. So let's create an example of looping over all our lights and changing their intensity. Let's have their intensity. Let's cut them in half. So what we want to do is we want to ls, we get all the lights. Let's save them into a variable called lights. And then let's loop over each one and set their intensity. Now, how do we know how to set their intensity? Well, let's do a little experimentation. We can pick one of these lights, and we can go into the attributes. Oops. And we go to the attributes. Now, my window's kind of small, so I have to look at this closely. Here's the intensity. And if we just set it to itself, we can see really easily how to set the intensity. It's the intensity attribute, and you just pass it a float. And so what we do is we do our for loop for L, or we could say for light, in lights, and that's going to loop over our light list, and enter, tab. So for each light, we want to get the original intensity, intense equals commands.get adder, and what do we want to get? Now we want to get the intensity. Now another way you can get the attribute is get attribute works if you put dot intensity and we don't build a string with the name of the node, it's going to work on whatever's selected. So here's another way that you could do this. You could commands.select the light, and you remember that R means replace everything else. You saw that when we were doing this right here, replace the previous selection. So now it's going to select that light, and now we've got the current light, and we can just say dot intensity, and that'll automatically do it on the current selection. So we want to get the current intensity. Then we want to say new intensity equals, and we want to do half, so we want to do intense times 0.5, and that will give us a new intensity. And then we can go back and say commands set attribute dot intensity new intensity. And so theoretically, when we run this whole thing, it should loop over every light and have the intensity. So let's hit this. And what we could even do as a bit of feedback is after we set each one, we can use our print command, and we can say print, let's say print the light, comma, because you can separate your elements by commas, old equals intense, new equals new intensity. Let's run this and see what we get. I'm going to clear this area so we can have a fresh canvas here. So I'm going to hit enter. Now, what happened here? Did I misspell? I misspelled something. Intensity, intensity, intensity. See, Python helps you out. Tells you that there was a name error. New intensity is not defined. That told you that on line 6, you see on line 6, it got to line 6, and I had a bad name here. So I knew that I needed to fix the naming. So I'm going to hit enter. And you can see what happened is it looped over every light, and it told you that was the old value, that was the new value. So what's really cool is we didn't have to go through each light and select it and do the math and figure out what half of each one is. We could just loop over each one with a common value to change them all by. And again, we could wrap this up into a function and pass it a list of lights and even another attribute for the intensity to change it to. And that way we have a function for changing all the lights in our scene. And actually, let's do that. Let's turn this function into something where we can use it like a utility. Let's create something called gain lights. And actually, I'm going to undo what I just did to the lights, put them all back to normal again. Gain lights. And let's make some room. Gain lights, and then we're going to do parentheses, and this is where we can define what attributes we want to take. So I think the first attribute should be the lights list, right? And then the second attribute we could put is the gain that we want to apply. So I do our colon, and then select this here, tab in. The space here is perfectly fine. You can have spaces to separate and make it more readable. And now lights is now called lights list, so we need to make sure that we use the right list inside our command. And what else do we need to change? Well, we have this hard-coded 0.5 right here, but now we want to make this a variable so that you can call it with any type of intensity. So what we would do is take this gain value, put it right here as a placeholder, and then we can select everything, hit enter. We now have a new function, right? And this new function just takes a list of lights. So what I can do is I can call gain lights with, and you remember we got our listing. We would do this outside to figure out what lights we actually want to use. So in this case, we just selected all lights in the scene. I can call this, right? And now if I hit enter, we're going to get an error because we have to take two arguments. How much do we want to gain the lights? Let's gain it by 2. Let's double the brightness of everything in the scene. And look at that. And then we could run it again with 0.5. And it drops everything down into half. So you can see that now we have this cool function. And if we were to, let me get rid of this. Let me get rid of this. Now if we were just to take this script, actually I didn't even need to do that. I will just select, because the save function works on whatever you select. I could say File, Save Script, and let's call it Gain Lights. And this doesn't have to be the only thing. You could save lots of functions, and when you're starting out, this is pretty much how you will write your utilities, because you can get more advanced in Python, but to start out you just need these functions just to get you going. So you can make a whole file full of utility functions, right? And so what I can do then is I can load this script in, and then I can call, I just have gain lights now, so anywhere in my code I can just gain lights, and I can always just load it right back in. Right, there's our gain lights tool. But to actually use this, if this Maya had been freshly started, let's actually just prove that right now. Let's see what happens here. I'm going to copy this. I'm going to close Maya. I'm not going to save. Right? And then I'm going to open up my scene again. And this is something that we'll get to later in the video, but it's something that I just want you to be aware of right now. So when I load up Maya again, and I try to run my gain lights function, it doesn't exist because it's never been entered into Maya's interpreter yet. We have the code here because it was saved from last time, and if it wasn't here we could have loaded it, but for now what you would have to do manually is run that, and now you have this function all over Maya anywhere. Even from right here you could run that gain lights command. But later on in the video I'm going to show you where you can put these scripts so that you can import them just like a module, so that you could do something like import Justin's utils, you know, and then we would get Justin's utils dot gain lights, that kind of functionality, and that'll come later on in the video. Alright, so let's clear the scene so that we can try another example. And I'm going to clear this, and I'm going to create a new tab, New Python tab. In this example, we're going to try to solve a task that's a little more complicated than just selecting lights and changing the intensity. What if we wanted to, say, create a spiral type structure out of, let's say, spheres? We want to have a function that can generate a spiral. And we'll use spheres because it's an easy object to work with right now. We've seen that command before. So let's start off with the concept of how to create the sphere. We already know that to do a sphere, we can call sphere. And we know that sphere has, we got to turn on some help. There we go. We know that sphere has options. And let's open up our actual help screen and look at sphere and see some of the stuff we can do with it. And something we can do with sphere is we could set the pivot. So when we create the sphere, we could create it offset from the center. And so I think the idea of what we could do to solve this problem is to create a bunch of spheres over and over again with a pivot that's off center, and then rotate them around, say, the y-axis. And if we do that over time, we'll get a spiral effect. So we'll make use of this pivot flag. Let's go back to Maya, and let's say pivot equals. Now if we go back one more time, we see that it takes a list of 3 numbers. Maya calls linear a number, so it can be a float or an int in this case will work. And we can either it will accept either a tuple, like I told you in the parentheses, or a list. We'll just do exactly what it asks for and give it a list. So what we're going to do is let's just give it, let's say x is 3, and then y. For now, I'm just going to put 0 and 0. Okay, so this is going to create a sphere. I'm going to move this over so we can see a lot more. Okay, so we've got this here. We're going to create a sphere, and let's see what happens here. We've got our sphere. Okay, I'm going to delete this. I'm just going to keep moving through this kind of quickly. So we've got this sphere, and we want to make a bunch of them. So how do we make a bunch of them? We make a loop, just like we talked about before. We do for, and we'll call it a counter. Now, how many do we want to make? Let's say we want to make 20. Now, I told you one way to loop over numbers is there's a command called range. And if you put a number in there, you get a list generated for you that you can loop over. So if we say for I, and I is just our counter, we can call it anything, in range, create 20 spheres. So if I run this right now, I just made 20 spheres all on top of them. And you can see that by moving, and you can see there's 20 spheres in there. If I select them, you can see all the spheres. So again, let's delete that, and we're just building this bit by bit. So we're creating 20 spheres, and what we want to do is vary the height so we can create them over time. So this is the height, y, and we want that to increase over time. So what we could do is we can start height equals 0. That's our height attribute, and over time we're going to increase that. And so we can say, instead of saying 0 every time, let's set y to height. If I run this now, we're still going to get 0 because we're not making height any bigger. But what I can do is every time after I make the sphere, I can say height equals height plus a certain amount of increment. Let's just say 1. And if you remember, we can actually make this shorter. We can say plus equals 1. So every time this loops, it's going to create a sphere, and it's going to increment the height by 1. Let's see what happens. Okay, so we're getting closer. We've got spheres going up in the air. Okay, let's get rid of all these. I probably could have just undid it. There we go. That's much easier. Okay, so we've got spheres going straight up in the air. Now that's getting closer, but we need them to go around in a circle. So because we're using a pivot and they're offset from the center, let me just do this one more time so I can show you. Because they're offset from the center, we could actually use, the rotate value and rotate them over time. So let me select them all and get rid of these again. Okay, and so what we want to do next is let's do commands, and to set an attribute, if you remember, we do set adder. All right, and then now we didn't save our name. We need to know the name of the sphere each time. So let's come back to this for a second. Let's create a name for our sphere. Let's say this name equals spiral sphere, and we want to make this unique. So every time that this loops, I is a new number. So we could tack on I, and we could say plus I. Now if you remember from earlier, if we try to add an int, which is going to be an int out of here, and a string, we're going to get an error. So we could do either force this to be a string, or I could teach you something really cool to stop having to force things to be the string like that. There's a thing called string formatting, and it's okay if you don't remember this, but I'm just going to show you another way you could do this. What you can do is you can put little patterns, little wildcard patterns in here, or placeholders, where you do %, and for a string, it's the S key. If you wanted to force something to be a digit, you could put the D key, but if you put a %s in here, you're creating a pattern. And so what happens is, and let's not do a space. Spaces aren't very nice, so we'll do an underscore. And what happens is you can tell it what to replace those with by doing a %i, like that. And I could have more patterns in here. I could put %s again, and if we do that, we need to wrap this like that. But let's just keep it simple. So every time this loops, it's going to be called spiral 0, spiral 1, spiral 2, and we've got to save the name. Let's say parts. And let's get some more room here. Okay. Let's call this parts, because we know from the past that sphere is going to return a tuple of, or a list of, the first index is the transform, the second index is the shape. So, and also we want to make sure that we give it our name. So every time it creates one, it will give it our name. And so we are going, so okay, so it's going to create the new name. It's going to create a sphere with our name, with our height each time. And we want to make sure that we get the transform every time. So that is parts 0. And I'm going to stop here and let us see what we're doing. Okay, and we can do that by putting a print in here. So let's see at the end of this. Let's see what print transform and height. Okay, so we're checking ourselves as we're going along. So I'm going to select all this, hit enter. Prints are a little slow. If you have lots of prints in there, it can slow down the process a bit. But you can see what happened was it went through each loop and it gave it a name, and these are all our transforms because we are printing the first argument in the list. If we had not done that, we would have gotten a list and we would have had the wrong item. So we want to get the first item in that list, and that is the height as it goes along. Let's undo and get rid of our print statement. And next, we want to make some room here, and we want to set the rotation. So we know our name, and we know that we can set the attribute by commands set adder, and our name is transform. That's the name each time, and we need to make sure that we turn it into the .rotate y. is what we want to change. And we could have checked that by changing the rotate value from the channel box, and it would have printed rotate Y, but I'll save us the trouble because I know it. So we're going to add that dot rotate Y. And if you wanted to make this even cleaner to read, you could do more steps here and say my adder equals this, and then it's easier to read step by step. You create more variables, but it's easier to see what you're doing. So we want to do my adder. Now, what do we want to set this to? Well, we want it to be in incrementing degrees. We want it to go around in a circle. So that means we need another variable because this needs to constantly change. If you said 10, let's do that. If you say 10, what's going to happen here? Oops. If you have some weird blank lines here at the end, sometimes it freaks out on you. So just make sure you select all this here. Okay, let's hit enter. Now, everything's still one after the other because, let's see the channel box, we set everything to 10. It's hard-coded. It can't do anything better than that. So, oops. All right. Sorry, it's really weird to work in this small screen space. There we go. Okay, so instead of doing a hard-coded amount, and let's get rid of all these, we need to make this a variable. So we need a new variable, and let's call it degrees. And we'll start it at 0. And if we switch this to degrees, you can see how we're starting to fill in the blanks with variables. We're taking out the hard-coded numbers and we're making variables. So every time this goes around in a circle, it's going to be degrees. So that means that next time we go in a loop, let's add to our degrees. Let's do 30 degrees. Every time it creates a new one, it's going to rotate 30 degrees. So it'll be 0, then 30, then 60, then 90. But if we go, well, I'll get to that in a second. No, let's do that now. Now, if we keep going for an extended amount of numbers, our degrees are going to get pretty unwieldy. So every 360 degrees, what if we just reset it back to 0 so that we're constantly going around in 360 degrees, and that makes much more reasonable numbers. I'm pretty sure Maya would reset it anyway for you, and give you the difference, but let's just, for the sake of doing this in Python, figure that out for it. So we want to say that every time degrees gets above 360, let's reset it back to 0. And we can do that test with an if statement. So we can say if degrees, and it's just like math, regular math, you can do greater than or equal to 360, and then we got to do our colon and jump inside. What do we want to do if degrees is greater or equal to 360? Well, we want to reset degrees. Now let's not reset it, but let's set it in case it were to ever go 370, and we want to make sure we get our spacing accurate. So let's say that it's always degrees minus 360. So that means that if we're 370, this would make it back to 10, and it would climb up again and then go back around in a circle like that. So we're resetting a nice clean degrees value every time, right? And so what we want to do now, I got something blinking, let me get rid of that here. At this point, we have everything we need to address our real-world problem of if we had that scene that had the missing textures and we wanted to fix all the missing textures in the scene in a loop automatically. We know everything we need to know now, so that's what we're going to tackle next, is solving that real-world problem. Alright, let's solve those missing textures in our test scene. Let's open up our Canon deck broken scene. And as we remember, the textures are missing. And let's get our script editor open. And we're going to open a new tab, Python. We got our clean tab here. Let's clean out the window, get something we can see here. Alright, so the first thing that we want to do is get all the textures in this scene that we want to work on. And what we can do here is, if I click on one of these items here, and go to barrel, and it's telling us all the textures are missing, obviously. And if I jump into our texture, we can see what's important here is the type of node that this is. And if I scroll down here, again, bear with me with the small window, but you can see, okay, here's the image name. This is the image that this texture is pointing to, and it's a file node. So this is the node that we're looking for. We want every file node in the scene. And from before, we use the ls command. So if we do commands.ls, and doing that gives us everything in the scene, but we were able to limit the search by the type. So let's do type equals file, because that's the type of the node that we're looking for. And that gives us every file node in the scene. Now that we have every file node in the scene, let's save that into, let's call it file nodes. Okay? And then what we want to do next is we want to loop over every one of these file nodes and fix it. So to loop over, and we do for f in file nodes. F can be anything we want it to be. And we do our colon at the end, tab to go inside of our loop. And let's start off simple, and let's just select each one. So commands.select f, and you remember to do r equals true. That means replace the previous selection, which is a safe way to make sure that we only have one thing in our selection. And so this is a simple way, because now we can check out the attributes of each node. So and to verify that we are selecting each one, let's just put a print here, print f, and see what we're doing so far. So if I select all this, you can see that we are looping over every single file node in the scene, and we've selected each one as we went along. Alright, let's get rid of this print statement. And what we want to do next is we want to get the current path to the bad images, because we want to fix it. So we want to get this, and we want to get this image name, but that's not really the attribute we're looking for. And I told you that the easy way to get that is to just, you can just make a little space change here, and it'll print, see right here, it tried to set it, and it tells you it was setting file texture name. That's the attribute we want. So let's take this attribute name. And we just saw that by playing around with the attributes and seeing what they're called. So we've selected each one, and now we want to get that path name. So let's call this full name, because it's a full path name, equals commands.getAttr. And I had mentioned before that if we have selected the node already, we don't have to build the whole attribute name. We can just say dot file texture name. And to make sure where we're at so far, let's print full name. Alright, so we have got all the textures attached to these file nodes. And what we want to do next is we want to fix it. This is the bad part right here, because in our project we have a textures directory, but this part is all from Billy's setup. And what we want to do is, if we could just get it down to this, Maya will look inside the current, we've set our current project, from setting the project, and then we've pointed it to our project directory. And so let's open this up here. Maya will figure out that it needs to look in this textures directory for all our textures. So we need to get rid of this front part. And to do that, let's start with a way that's built into these objects, and then we're going to look at how we can expand it later. But what we want to do is, because each string is an object, it has all these great things it can do. And like I said, just ignore the underscore system. Oh, Maya doesn't want to scroll. All right, let's try this again. Maya's being a little buggy with this pop-up window. But what we want here is we want to split. You see? Let's see if it'll show us some output here. Okay, we want to split this string. And what a split does, if we want to find out, is right? This will tell us split takes a separator and optionally how many times you want it to split. So let's get rid of this here. And what we want to split on is these path separators. Now bear with me because I'm on a Macintosh, and this would be correct for Linux and Mac, but for Windows you would have a backslash. I think Maya will fix it either way for you, but what I'm doing is somewhat assuming that it's a forward slash, but just for this example, let's do forward slash, and let's see what we get with that. Let's put a print in front of that. We get a list every time that split the path up by the slashes into its components. And what we want is the last, just the name. We just want to get the name. We'll build the rest of this later. Let's just take the name off here. So what I said that you could do before with lists is you can index them. So we want, and you don't have to, we could say parts equals, and then down here we could index parts being a list, but we could do this all on one line, and we could just say -1, and that says give me the last item of this list. And the way this evaluates is this says full name dot split. This becomes a list, and then on that list we're going to take the last item in the list. So let's call that name. Alright, so we can say print name. Alright, we got the name of every file. Moving along. Let's get rid of that. And now what we want to do is build what the name should be. So let's say new name equals, and then we want to do textures slash name, because textures without anything in front of it, this is a relative path. So this is going to say look in the textures directory under our project plus the path plus the name. Print new name. Alright, so now we've got our fixed name, and we want to put it back into that original node. Alright, so we want to do a set attribute. So commands set adder, and the first argument is the file texture name, and then we want to give it what we want to set it to. Now get ready for this possibly not working, and I'll tell you why. Alright, we got an error, and the reason is, and it's telling us where our error is. On line 7 we got an error with the set attribute command. So if you look down here, now it's saying that this attribute is not a simple numeric attribute, and you have to set the type if it's not a numeric attribute. So that's something, before when we were doing our spirals, we would just say the number 10 right here. So if it's a number, it doesn't need you to tell it what kind of type the value is, but because we are using a string, let's look at set adder. Actually, set adder. The type takes the name of the type, and we can pull up the actual name, or we can pull up the help. And I'm going to pull up the help right now. And if we go to set adder, you will see that there are all these types that you can define, and it's because it's a mel. This is all wrapped around mel, so mel needs to be told what kind of value you're passing it. And if we look down here in this list, we will see that the one we want, there it is. It's a string, so we have to give that type. So what we got to say here is type equals string. If we were, say, giving a color value, and this was like, you know, 1, 1, 1 for RGB, then this type would probably be 3, and you can look that up in the documentation. But really, all we need right now is this string. All right, so we should actually have this fixed when we do this loop. Let's do this now. And watch the path right here when we hit enter on this. You see what happened? The textures switched. All the textures are back in the scene, and our scene works. Now, we could say that we're done, but I want to do a little cleanup on this code to show a couple things that we talked about earlier. So I'm going to undo this. And actually, we could run this as many times as we want, but I'll undo this. Anyway, we don't have to undo it, but I want to show you how to clean this up here. Now, you remember that instead of selecting each one, let's not change the selection every time we loop. Let's just build the proper string and put it in here. So let's get rid of this select. Right? And then let's build the right combination of this attribute and this path. Let's just say attrib equals, and you remember how to do it. We could add them together because they're strings, but you remember our string formatting. If we do %s dot file texture name, and then you do a % at the end, and that formats the f into this pattern. Now we don't have to say that attribute. We just pass our attribute. We can set it down here as well. Right? So that cleans that up. We don't have to change the selection every time we go around, which is nice when you build a big script and you don't want to have to change the selection constantly when you don't have to. And another thing that I want to change is, remember when I said I assumed this slash to separate paths, and that works great if you're on a Mac and you're on Linux, but Windows, you could have issues when you're assuming that kind of separator. So I want to make use of a module now. And one of the cool things is the OS module that we showed in the examples has a submodule called path, and that's for doing things with path strings. So we can say import OS, and I could just run that by itself. And OS has a module called path, right? And path, one of the things that path can do is it can split. And it can split using the proper separator, not you telling it what separator, but the actual proper one for your system. So let's fix this line. And the way it works is, let's go down here and get some help. os.path.split. It splits a path name. You just have to give it the p string path name, and it returns a tuple, which is like a list, but you can't change a tuple, in two parts with the head and the tail, where the tail is everything after the final slash. So that's pretty much what we want it to do right there. We want to say os.path.split, right? And that's going to give us back these two parts, but you remember we need the last part, not both of them. We need just the last part to give us a string. So we need to still do -1. But the cool thing is we didn't have to assume the separator. It'll do it for us. And let's also fix this texture name here while we're at it. Actually, let's make use of the OS path again. There's another item called join, which is the same thing but the other direction. If you give it two or more path name components, it will insert the slash or whatever it is for your system. So let's say os.path.join, and this takes, you don't need the slash because it'll figure that out. You give it as many pieces of the path as you want, and it will join them together into a string. And we can run this again, and we shouldn't get any errors at this point. See? And it ran, didn't give us any errors, but it still did everything it was supposed to do. So that's how we clean up the code and make use of some modules, and we fixed our scene, and now our scene has textures with no errors, and I will save that out as the fixed scene. So that takes care of our texture fixing scenario. In this chapter, I want to get a little more in depth about development in Maya, some details about what's available to you. And I know I talked a little bit about Python versus Mel and the differences between Mel and Python. And while Mel is the basis of Maya's UI and all the code that you see flowing out of the script editor. And it's, like I said, you could learn it, and it's good to learn it for the reason that it helps you translate the code that you're seeing as you do things in the scene. And it also helps you when you read other tools that were written, so you can write equivalent Python. So it's good to look at how the MEL works, and you'll get a sense of that as you see the code flow out of the script editor. And you just know the difference between the flags, whereas Python just uses the keywords. But Python pretty much does everything that MEL can do, and a lot more overall, like having that OS module that we used. But another thing that's available in the latest, it's been integrated since Maya 2011, it's something called PyMel. And I'm just going to introduce what PyMel is, but I don't want to get too much into it. It's beyond the scope of this tutorial. But PyMel was developed by Luma Pictures, and they worked on it for so long that they ended up integrating it directly into Maya. People used to use it, install it, but now it's actually shipping with Maya. And the way you would get it is import. This is the common way people import pymel.core as PM, which just means that we're going to alias this PyMel core submodule as the word PM. And it takes a second to load, but once you have it, the thing behind PyMel is it was an approach to make the Python side of coding more like Python and less a wrapper around Mel. So the idea is to make things more object oriented and more functionality. But the reason that I don't want to get into this, I don't recommend learning it to start, because it's too much different than Mel, and I think it's important to learn the actual Python commands as opposed to learning something third-party that could change over time. And also there's another reason, is PyMel is significantly slower to process in terms of speed than just the straight commands module, because there's a lot more overhead. And I'll show you an example. The way we can make a node is PyNode. If we want to convert the name of a node into a PyNode, so I'm just going to take this file that we were working on earlier, and I can say file 58, and oops, I didn't spell that right. There we go. And that gives us back an object, whereas before we were working on just strings, and strings can't do all that much, but these objects that they've written, let's see, let's call this our F node, and they make these smarter than the average string. There's a lot of stuff that goes into these, and basically what it goes into is, instead of having to call commands get adder, we can just say f dot, and we know that this was called file texture name. This texture here, we know that was called. So all you have to do is say file texture name, and that under the hood does a get adder for you, but it doesn't even return the string path. It now returns an attribute object, and that attribute object can do everything you need it to do. And in this sense, we can just say get, and now we get the string to the full path. But this object can do everything. It can set connections from here to be driven by other properties. You can set this way, but that's the idea behind PyMel, is it's meant to make everything much more object oriented. And another reason that PyMel has its pluses is because it gives you access to what's called the Maya API, the plugin API, which is a lower level coding language where you can do it's usually you would use C++, but you can also use Python to access it, and that's where you can create your own custom nodes, and you get more advanced, and you can get into the lower levels of Maya, the things that the commands can't do, like you can get more control over the undo stack and things like that. But PyMel wraps all of that into these objects, which means there's a lot more overhead. It runs a bit slower, but it is significantly easier to use. But I recommend not learning it right now. You can get into it later to accomplish some more challenges, but we should kind of stay away from it for the moment. And the rule of thumb is if you want ease of coding, then you can use Pinode or PyML. But if you need speed, if you need to loop over lots of geometry and points and things that are doing lots and lots of loops, then PyML is going to be too slow. You're going to need to just stick with the commands that we've been using. So that's it for this part of the chapter. And what I want to talk about next is the Maya environment, how to set up Maya to be a little more useful with the code you're writing. So what I want to talk about this point is, now that we've gone through how to use Maya with Python, and you know how to write your scripts, it's a little inconvenient the way we've been doing it to constantly load and save the scripts like this. I mean, it's a good way to use this for your editor and to save the scripts, but to load them back in and select your code and hit enter and commit them every time you want to access your tools is very inconvenient. So I want to talk a little bit about how to customize Maya's environment a bit to make things more convenient for you. And let's talk about, the first thing is some special paths that Maya recognizes. So I'm going to open up the Maya help. I had it open because it takes a little while to load, but if we search for file path variables, the first result we get is it's got a list of paths in here, and these are all paths that Maya looks at. And the important one is the Python path. And for Windows, and it's different for Linux and OS X, but these are the order of paths that Maya will check for Python scripts. And it's the same with Linux. And they don't put scripts at the end here, but I don't know why, maybe it's a typo, but there should be a scripts directory. And this is what I'm going to use: home directory, library, preferences, Autodesk, Maya, 2011, scripts. And what I want to do first is, if you remember, this is for our learning purposes. When I type commands, now I have commands, but if I hadn't imported, I would have gotten an error, because I had to do import maya.commands as commands. And we can first off make that a little more convenient for us. So let's open up a shell, and I'm already in my Maya scripts directory, and I have nothing in here, but there's a special file that Maya will look for when it's starting up, and that's called user setup.py. that you can also do mel, and it will look for one of those, but it'll only run one if you have it. So let's just do user setup py, and you can use whatever editor you want. I'm using this in a terminal, but what I can put in here is import Maya commands as commands. I'm just going to keep that in here. Now you can use this for all kinds of more advanced things, like adding paths to where Maya will look for these if you're going to set up a network and have a bunch of artists pulling from a single path, but that's kind of beyond the scope of what we're trying to learn here. This is just for our personal use, and you can look into that more or wait for the intermediate level class to talk about that. But we're just going to put this in here for now. So we have this file that has that one line in it, and if we reload Maya, the scripts editor will always have that commands module available. And now what I want to do is bring over our scripts that we made. Now you remember the create spiral and the gain lights function, and what I did was, when we were paused, I made this learning module with just copy and pasting these two pieces of code into here. And I'm going to show you. That's all I did, was just paste these commands in here, and then I cleaned it up a bit, and you can see what I did here was, this is called a doc string, and all it is some help. You see, when we did the help command, we would get some output. You can put anything you want between these quotes, and this is an example of how to do that at the top of your function, to put some help in there. And I just cleaned it up a little bit. But one thing that this tool is missing is, when you run these inside of Maya, you're running them in the main, what's called the main namespace of Maya, the global namespace, where it had the import command statement. But when you're going to bring it in through a script like this, you should always do import Maya commands as commands, because what lives inside here only lives in this file. When I make gains lights it's in this file. When I make these variables, it's in this namespace. So you need to make sure to import all the modules you use. If you were to use the OS, you need to import the OS module. So you need to do your imports right here at the top of the file. So this one's usually the most important for writing these Python commands. So I'm going to save this. Right? And now what I'm going to do is I'm going to copy it over. So I've got these two files now. I've got my learning module. I've got my user setup py. And what I'm going to do is go back over to Maya. And I'm going to say import learning. Now learning came in. What's inside learning? There's our two functions that we made. They live inside the learning module, and we can access them just like we've always been doing with the dot. So let me go back here. And before I do that and clear the scene, I just wanted to say a thanks to my buddy Edwin Porfert for donating this scene. He created all this and gave it to me to use freely and distribute it for you guys to use in the examples. So thanks again, Ed Porfert, for designing the scene and giving it to me to use. So also before we clear the scene, let's also try our gain lights method. So you remember we had learning, gain lights, right? And if we do help learning gain lights, there's our help on how to use the gain lights, and it takes the list of lights, takes the float, and to use gain lights we need to get our lights, and this gets all the lights in the scene, right? And then we just pass that in to learning dot gain lights, and we'll gain it up by 2.2. And all we had to do in starting this new scene was import our learning module, and we have all our tools. And so you can also do the, let's clear the scene here. We can also do learning create spiral with the default options, and there's our spiral. We didn't even have to type out or load any code, just import that learning module. So you can see how setting up the environment makes your developing a lot easier. And you could pass this learning module over to other people to put in their scripts directory, or set up a common shared one, which is a little more advanced. But you see how now all you got to do is write new functions and drop them into that module, or make new modules and name them however you want. And once you have these functions that you can access, then we can actually make a shelf button. So if we go over here and we say the shelf editor, and we bring up our shelf editor, let's put it over here. And if we go to, let's create in our custom, I already had this, but I'm going to delete this here. Right? Won't delete it. Well, let's create a new one anyway. Let's say create spiral. Right? So we've got the spiral. We could set an icon, but we won't do that right now. We'll go in here, and it's asking you if you want Mel or Python. In this case, we want Python. They give you some temporary code. You put it in there, and all we have to do is put in learning create spiral, and that's going to call it for us. So we can go back over here, save all shelves, and we get another icon, and I can close this down. I can do the scene over, and I can run that, and I get nothing. There we go. You get create new spiral. I had the wrong icon. So you can see how you make buttons out of your commands now, and you can make as many as you want with all your functions and put the variables in there. And that pretty much does it for learning Python. And we have I'll do a little bonus information after this about creating a simple UI, just to give you enough to understand how to bring up a little pop-up and give you some options for your spiral. So we won't go into too much detail about that, but that'll be next. Alright, so to finish out this tutorial, I wanted to give you a little bit of a bonus chapter to just show you a bit of how to create a dialogue to wrap around one of the commands we made. And this is bonus because I don't want to go into too much detail because it's a whole nother section on how to work with designing UI, and it's all in the help document, the commands, the Python commands document that I showed you. But I'm going to include the script with you with the project, so you can check it out. But let's just take a look at what I threw together. I'm just going to go into File, Load Script, and I created this script for you while I was away, and I'll include it. It's the create spiral win to accompany our create spiral. So I'm going to load it, and it's a little bit more code than we've seen before, but I'm going to go through it and just tell you what I wrote, and you can examine this in your own time and play around with it. But what I've got here is I've got our basic import commands like we always need. I've got our import learning because we wrote our learning module that had our create spiral command in it. It could have been also called create spiral because we have that in there as well, but we'll call it learning. Oops, did I get rid of that? Let's get that back. Yeah, so we've got our function that we made, and I called it create spiral win, just so we know that it's this command, but it opens a window. And the first thing it does is it creates a window for us, and with a title and a default width and height. And then we add this thing called a column layout, which there's different types of layouts for all your little widgets in the window. And this basic type is called a column layout, meaning that all the following widgets that come after this will be vertical, just like this, until we move up a parent again. So we run this column layout, and there's some options on how to format it. And then we start creating widgets, and we create 4 field widgets. We create a float field, and you remember we had 4 arguments to our spiral. We had the amp, the spin, the count, and the width. So I'm going to create these float fields, and they have a label and a default value for these were all our defaults that matched our command. And so I'm going to create 4 of these. This one happens to be an int field because our count is how many spheres to use, and we only want to make sure they can pass in a whole number, not a half of a sphere. And so we've got these 4, and they're all going to be in a row. And then, and I'll explain what this is in 1 second, but we create a button, and this is our create spiral button. And one of the features of the button is you can specify the command to run when the button's clicked. So what I did here, and this could be a lot more advanced, but I'm trying to use just the absolute bare minimum Python that you could be familiar with to understand what I'm doing. Generally, you could spruce this up even more, but what I did was I created a function inside of my function. So this function only lives as long as this function is alive, and afterwards it goes away. But I create this function that calls another function with the name of my widgets. It calls it with the amp, spin, count, and width. So when I click this button, it's going to send the names of these widgets to this command. And we'll move down the code here. I create another button right here. That's the close button. And the command is to close the window. The other way you can specify a command is just by putting it in a string, like this. So one way is to create a real function object, and the other way is to actually put text into a string. So I pass this in here. So when I click this button, it's going to close the window. And the last thing I do is show the window. Now down here is a second function, do create spiral. And I reference that right here, and I pass it the names of the 4 widgets. And they come in here, and I get the value. And you can see I get the value because I use this flag called query equals true, and then I tell it what value I want to query. So for each of these, I'm getting the value of that field, and I'm storing it right here. And then I'm calling our, you remember this, our learning create spiral with our 4 values. So once I click the button, and let me show you, if I select all this and hit enter, and then I run our window. We get a window, and the layout's very basic. I said it was a column layout, so everything's in a row. We've got our float fields, our int field, float field, and I can hit this create spiral. It creates our spiral with these values, and I could even change the amp. I could say the amp is 2, the spin is 15, 50, 2, and it makes another spiral. And then when I hit this button, it runs the delete window command that I had right here. And to make this part of our code just like we were doing in our previous examples, I am back in my scripts directory, and I copied it over into the directory. And these PYC files, if you see them, they're just the optimized files that get generated after you start running the commands. So don't worry about these; they get made automatically. But here's our create spiral win. So when I put it into this directory, it becomes available to where all I have to do is say import create spiral win, right? It imports it, and then I can call it. And the reason I have to do it like this is because, remember, I'm importing the module, and inside the module I had that function called create spiral win. So I can run this, and there's our dialog. And from here I could put this into a button. There we go. Let's see here. Now they're all coming up backwards. There we go. So now that's how we make a very simple interface to wrap around our very simple function. And at this point, I wanted to thank you for sticking with me through the command line Python and getting into the really cool stuff for learning Python in Maya, the intro course. I hope you learned a lot. My name is Justin Israel. Look for the future videos that we'll make to expand upon this topic, and good luck playing around. We'll include these project files with you, and we'll include any kind of contact information. If you have any questions, you can always email me, and I'll be happy to try and help you out. All right, thanks a lot.